Hello and welcome back to day number 3 of the lockdown special elements. We're going to be doing sodium, next one on our list. Remember, I'm not doing 1, 2, 3, 4. I'm going down the lists. And just to recap, that's because everything in these groups, they're similar. And I wanted to mention, I didn't the other day, because you might get confused, hydrogen is in the same group, but it's not, it's a gas. It's not a soft silvery metal, which is super reactive with water. Well, it is if you put it under enough temperature and pressure. There's a thing called metallic hydrogen. If you squeeze it enough, which is what is happening in the center of our supergiants like Saturn and Jupiter, and if you carried on with that compression, you'd end up with nuclear fusion. You'd end up with a sun, 2 mini suns in our own solar system. That's scary, but luckily they're not doing that. Great. 1 sunrise a day is enough. First confusing thing is its symbol is Na. That's really annoying. I found when I was looking at the table, I'm dyslexic, so when I was looking at the table, all these numbers and letters just threw me right off. And then I got really confused and angry at the fact that, well, hang on a minute, why do you call it Na when it's sodium? Maybe SO would be a good idea. No. Sodium was discovered by Sir Humphrey Davy. Here he is. He was a Cornish chemist in the 16th century. And sodium is named because he used caustic soda to isolate the sodium, and he called it Na after natrium, which is a valley in ancient Egypt, where the valley itself is about 100 feet below the Nile level, and it's full of alkaline lakes with these salts in it. Very important for their industry at the time, and one of the things they used it for was the mummification process. So that explains the Na being different from the sodium, just to confuse you. Now its atomic number is number 11, which means it's got 11 protons and 11 neutrons in the centre. Here's a graph, or a pic. And it has 11 electrons whizzing around the outside. Now it's at this point that I'll begin to explain, and this will give you an idea of understanding why these are so reactive. So if I pull up, we'll pull up hydrogen as well. Hydrogen, lithium, sodium, potassium. I could do rubidium and cesium and francium, but I won't at the moment. 4's enough. Now you will notice on these 4 graphs, you have what's called shells or orbits. It's the circle where the electrons whiz around at 1% the speed of light. That's really fast. In a blur, by the way. It's not in a neat circle like this. This is done so you can sort of simplify it and understand it a bit. I'll go into the orbits later on. But you'll notice one thing in common with all 4 of these elements, and that is in their outer shell, they just have 1 electron. One. That's all. 1. Now, the elements don't like that. They hate having 1 electron in their outer shell. They like their outer shell to be full. In hydrogen, for example, it has a shell which can just hold 2 electrons. Now, it's got 1. It doesn't like it. That's why it's reactive and it explodes. And the next outer shell, you've got 2 in the centre, then you've got 8 possible electrons. Lithium has just 1, because it has this inner 2 filled up, and then it has an extra electron on the outside. Also, the reason for it being reactive. And that carries on going down the graph. And because the electrons get further and further away from the centre of the nucleus, their bonds begin to break, and so those electrons will even move apart even quicker, easier. So they're even more reactive. They hate having this one extra electron on the outside. And they will grab it from something on this side, usually. There's some cracking examples. The obvious one is if we get hydrogen and oxygen, you get water. You take sodium and chlorine, you get salt. Another good example is hydrogen and carbon, you get oil, which is really low and cheap at the moment. They're almost giving it away. So this side likes to marry up with this side because this side has an electron they want to get rid of. This side has an electron, not this one, not the noble gases. Forget about them. I'm talking about the halogen group. I'll go through that. This is the reactive group here and the reactive group here. These ones, they're not interested in anyone or anything. They're quite happy by themselves. They are complete. They are noble. Nice. So that explains a little bit into the shells and their orbits. I'll go into that a little bit further. Let's take a closer look at the card. Now, first of all, you'll notice in the top here we've got some salt crystals because sodium chloride makes salt. Very important for your body. It helps with the nerve conductivity and it balances the fluids in your tissues and body tissues and blood. Vital for life. If you look, he's burning as well. As I said, they've all got flames behind them. I've tried to design them so the colour of the flame is the same as the colour that they will burn in real life. And sodium burns with this beautiful orangey green, orangey yellow light. Used to be the colour of street lights because they had sodium vapour in them. Next thing, can you see he's leaning over and sort of like making a nuclear symbol frost over because they use sodium as a heat exchanger in nuclear power plants. And finally in the background, can you see that there is there's a plant. Now that plant is called glasswort. Now glasswort is a plant which loves to live in salty areas, salt marshes, near the sea, coastal areas, and it's loaded with salt. It's salt tolerant. And in ancient times, when they burnt that plant, they had a soda ash. So, one of the things that you use it for is soap. Soap. I'll get that later. Sodium, they're using in experiments at the moment to get this is superhero stuff now, slow down the speed of light itself. Now, there is some really cool videos on YouTube on how that happens because it's all to do with wave oscillations as light waves go through it's crazy stuff, but this is true. They can slow down the speed of light from 300,000 kilometers a second down to 38 miles per hour, which is about the same speed as a good horse. And just to give you an idea how fast the speed of light is, if you were a superhero, you could fly to the moon in about 1.3 seconds. You could fly to the sun in just over 8 minutes. You could fly around the world about 7.5 times, but it will take you just over 4 years to get to our nearest star. Okay, so there you have sodium. Don't forget, if you want a copy of all the artwork on the of these characters, just check out Elements of Kapa, Google that, just visit the website, and there's a contact page there. Just leave me your email and I'll get these emailed to you, all the artwork, so you can have a look at that in high definition. It's quite cool. Alright, so I'll see you tomorrow where we're going to go over potassium, which is our 4th element. I'll see you then. Cheers.